ahead and share my screen. Cool. So this is just the Google Collab. We're gonna be working through the Google Collab though, right?
Yeah, Google Colab only.
Yeah. So all right. Because I was just looking at the repo and I just want
Yeah.
to make sure I understand what he's doing. So get it. So I'm not actually. I mean, if you look at the docs commit, yeah, I don't know exactly what we're even committing to this GitHub project. Honestly,
What
I know
did I just, what did you say?
I don't know what I'm even planning to commit to this GitHub repo here. Um,
No, so that's the thing I asked. Like, I don't think I mean, you wouldn't had need to like kind of fork it, because usually when you fork it, it's the reason to fork it is you basically hoping to uh, generate a pull request to their main repository, but base repository. But we are not going to do that because like that's not needed. But what you could do is like, I mean, for now you can just keep it, like you actually wouldn't need this repo for now. So just keep it as it is. Don't think about this repo, and we'll just work on that Google Colab sheet for now.
yeah. So this is more of just like a documenting our progress sort of thing.
Yeah. We could like use this repo to like just go through the concepts and all if needed,
Mm-hmm.
because this it's more like it has all the concepts, right? Like if you see the code files, the Python file and all, if you go back to that main root location, if you go to the hands-on ML3 root location, yeah, code, you can see all the important Python files are here. Like, so
All of
this is
these.
like good to like refer if any concept or something, how they are doing, how they're implementing.
Yep.
It's
Okay.
like a book, basically the ML book, but in GitHub format.
Yeah, just the code examples.
True. There should be content as well. If you go to the README, I think they should have some content as well explaining what that is. But yeah,
Oh yeah, yep. Here's all the code.
yeah.
Yeah, and then you can actually see what you're seeing too instead of typing all the code yourself. Okay, cool. Yeah, this is good. Just as a reference. And then you said there is a README. You said
I
here.
mean, you can see down there is the README file. It should have some content. Like, so just keep on scrolling what exactly they have. You can see. Yeah,
All
that is the book, I think.
right. Yep.
Okay, yeah. It did not have like all content, just like setting up the environment. That's it.
Mm-hmm.
So this is, I think, local setup, Conda environment and all. If you
Yep.
want to locally do it.
And then if they want to,
Yeah, I mean nowadays like
gotcha. Cool.
very few people do it locally. Like everything they do through cloud.
Yeah. Nah, this makes sense. But we're actually gonna be just working with the Jupyter notebook.
Yeah. Because we are not like, we are kind of doing a prototype. We are not like building a product for the customers, right? So for prototyping, I think uh, initially it's good to have Google Colab. Google Colab or like a Jupyter Notebook is good for prototyping.
Yeah. Cool. All right, we'll give everyone just a couple minutes to pop in. It's 5:59 right now. We got Sweeper. What's up? What's up? Janice. What's up?
So I have a question. So what do you guys actually do in this meeting?
So the last few weeks we've actually been reading through chapter 2. So we literally just read through the book line by line together, and if we ever encounter any words or vocabulary or concepts that people don't understand, we pause, we explore that, and we type the code. We just finished chapter 2 though, so we were like, let's build something. Let's build a model. Let's actually get some hands-on practice. And so what we are doing is, if you go through this repo, you're going to have all the information you need to get set up. But basically, what we're doing
Mm-hmm.
is we're using Kaggle. So it's a website,
Okay.
a community of machine learning engineers. And we have a data set of New York City taxi data. And so we're going to try to build a model with the New York City taxi data to predict current trip duration, I believe.
Okay.
Yeah.
Okay.
So This is my first model that I'm building without the guidance from a book, so this is gonna be fun. I think Aditya, you built a few, right?
Yeah, I know a few models. Like I mean, I've built some like during my masters as well. So Sindhu, since you are doing masters, then you could
Yeah.
take some courses on machine learning.
Yes, yes.
Has anyone else built anything or have any experience with it? Bitsy,
I've
Janice, Sweeper.
I've just worked on my assignments on machine learning. Yeah,
Uh huh.
pretty much the same. Yeah, I do take data sets from Kaggle as well to build models.
Okay, cool. Cool, cool. So I believe where we left off was, if you look at, so we just connected to the Google Drive, imported the data set, unzipped them, and now we have access to the data set with DF. So
Yeah.
I guess it's time to explore the data set, right?
Yeah, just run it at once. Like,
I did run all.
okay, okay, then it's good. Yeah.
Yeah, everything is good to go. Yep. So I guess thinking back to the previous data set that we analyzed, I'm going to keep the book open as well, just so I could kind of look through. Let me open this up.
Are we at the point where we're sort of thinking, oh, what are we gonna do?
Yeah, we're going to begin exploring the data.
Hmm.
This is probably actually better. So this is good because we have the end-to-end machine learning project and we have basically what we did. So this was just to get the data and then we're able to look at the different. So let me go ahead. I just want to type a couple things just so I can look at the data the same way that we did in the previous. So df.info. Let me go ahead and just.
First thing that the first thing that pops into my mind is doing that thing where you get a graph of like each thing, and it's, you end up with 10 graphs or whatever.
Yeah, let's see what attributes we have. So we have 11 attributes. We have an ID. We have a vendor ID. We have a pickup date frame, date time. We have a drop off date time. We have a passenger count, pickup longitude, pickup latitude, drop off longitude, drop off latitude, store and forward flag. I don't know what that is, but it looks like it's categorical data. And then we have a trip duration. Okay.
Yeah, just check head actually. See like what are the initial 5 values. You can see the values.
df.head.
Yeah, and add like 5 into it. Just add value 5 in it. Okay, yeah, by default it gives 5. So you can see
Yeah,
the values.
Okay. So it's giving you the date and the time.
Yeah, check that last column, like store and forward flag. What exactly is that?
A flag and
Yeah, if you go to Kaggle website, they like give you the description of what each flag is as well. To that project, taxi project.
okay. Sign in with email. All right. So New York City taxi.
I think it was NYC taxi. Yeah, New York taxi trip
There we go.
duration.
Yep, yep.
So if you go to data,
Hold on. How do I add this to my work just so I have it?
yeah, I mean like you could just like, I usually bookmark it, like create a bookmark folder and that add, like create a bookmark folder as like ML and then add that into it. Yeah, you can just create a new folder. Yeah. You can see yeah, machine learning. Just save it. So yeah.
Cool. All right, so data. All right. This
So-
flag indicates whether the trip record was held in vehicle memory before sending to the vendor because the vehicle did not have a connection to the server. So Y was store and forward, and was not store, not a store, and forward trip. Store and forward flag. Before sending to the vendor, and the vendor is the taxi
Yeah.
vendor ID code.
Then I don't think we need all the records which has n in it because it's not sent to the.
What do we think this is telling us? It could be, the internet is down or whatever, thing that might be involved with telling them the route. I don't know if this is like during the years where there's like
I mean,
things and whatnot.
so I feel like for that trip, we memory. So we could see like for that trip, what is the difference in the pickup and the like the start and the end duration of the trip, because that would be pretty high number. Like most of the values where the store and forward flag would be n would have pretty high values, so we can kind of normalize them to pretty low value, so that all data, because I think that's like a noise filter, that store and forward flag is like a noise in the data. So instead of removing all those records, we should like normalize that to like the other duration values, so that the data is normalized, because it's like basically adding a penalty to the uh, to the start minus end minus start time basically. So I would say better to like normalize it something to with certain factor, certain penalty, like reduce it so that then the data basically it's like it took time to for the vendor for the vehicle to reach to vendor, so we can just use that buffer and reduce that buffer in all those n values. Basic something like that we can do.
And this is store and forward flag. That's the name of the data, right? So if we got store and forward flag. So could I go ahead and actually check out? I think if we do df can we do this? What is the command? Value counts. Yeah, so you can see that most of them are not stored either. Only a small number of them are stored. And this just means that the taxi didn't have a connection or something.
Yeah,
Yeah.
I told you the removing won't work. We need to normalize it to some like reduce some penalty in all those values.
I still don't think we know what it means.
No, so what happened is I think so that n thing you can if you like so Jim, can you like do this? I mean I'm still trying to load the data because it's taking time for me. So can you do this, like try to find the difference in the values, like drop time, like time duration, sorry, check the time duration value. Like can you go to time, yeah, trip duration. So check that trip duration values for all n and for all y, like take some average of all the trip duration values for n and for y.
So you want to iterate through every single trip in the data set and find out what the average trip duration is?
Yeah, average value of the trip duration for n separately and for y separately. For n storage store forward flag separately and for y store and forward flag separately.
Okay, let's see.
Yeah, I'm also checking.
So if we're doing... So
one of the things that could, be connected to is, what part of the city you're in, because maybe it's a connection to like a, I don't know, a cell phone tower or something is involved. I haven't quite gotten to understanding what the technology is there, but it could be something like that.
I think what Aditya is saying though is that this attribute, he's hypothesizing that this attribute is noise in the data, and keeping this attribute the way that it is right now as far as categorical data goes is actually going to negatively affect our model. And so what he's saying is he thinks that we should minimize the effect that this negative feature has on our data. Now I think he's just like taking a guess, so we have to figure out for sure whether he's true.
Yeah.
But
And and I'm not telling to remove those values. Removing all the values which has n won't work, but like that n factor is bringing some penalty in the trip duration, like some extra time. So
Is
I'm
it?
trying to like say that if we could like normalize it back to like reduce that penalty. So then
Did it say that?
the thing is
yeah,
though, if I'm just saying, like, thinking about it intuitively, if the vendor doesn't have a connection to the server, if that's what this is saying, that they have to store the location or whatever because the vendor doesn't have a connection to the server, that could increase the time that of the duration of the trip, right? Because
yeah,
that would
well,
imply that the driver has bad service or the vendor has bad service, and they might get lost or take a wrong turn. So I don't know if this data is useless or noise. It might be actually valuable.
It's not clear to me if the n value necessarily means that the duration has been increased.
yeah. I mean,
But it could be.
yeah.
Let's read it again, shall we? This flag indicates whether the trip record was held in vehicle memory before sending to the vendor because the vehicle did not have a connection to the server. Okay, that sounds like a internet or mobile connection, which
I think it's just a flag that's saying yes, this vendor had network connectivity issues. That's what I
yes.
believe. Yeah.
Okay.
But all right. So
then
what do you, Aditya? You said that you wanted to basically find out the average duration for all the n's and in the average duration for all the yeses. So this will tell us. This will tell us basically what I'm saying. So do you know how to do that easily in Python?
Yeah, I'm just writing that code in the chat.
it might tell us something. If
You learned from last
the
week where I was just typing the wrong thing over and over, huh?
Well, it might tell us something, but it may also be if the error, if the internet errors are part of a certain territory, that they won't exactly tell us anything. If it's part of something that we can tell about time-wise, this weekend the internet was down because da da da, and maybe. But yeah, it's a good thing to check
Yeah,
the
so we
average
could
of each.
so we could see that the average trip duration is higher if they had to store. Yeah.
Yeah. Also check max value as well. Max and min value. Instead of mean, write their max. Like
Yeah.
no, don't remove. Yeah.
I'm just gonna
create a new-
copy. Yeah.
Yeah. Just change that max. I'm not sure if this works. Oh, but yeah. No. Yeah. Don't. It will print only min. Like if you do that way, it won't print both. So
Oh,
like
just do
either
one
define
one
a
at a
variable
time.
and then print. Yeah. Just see the max value for trip duration. Oh,
Wait. Uh,
what's the first one? Is it for
In
Y?
seconds.
trip duration. That's for
Oh,
now.
yeah, you can see the max difference.
That's
That's such a huge difference.
what is that in? What is that in minutes or what? Sorry, seconds?
Yeah, I think it's
Oh.
seconds. You can like, what's the? In seconds. Yeah, trip of duration in seconds.
Oh, okay, right.
So you
These
can
be-
see the difference actually.
Where does it say in
Could these,
seconds? Here we
the
go.
last.
Okay, yep.
these could be trips out of the city.
Uh, you could say that. I mean, you can see the latitude longitude difference as well. Like the pickup and the drop latitude. It's not like completely away
Let me
for
see
both.
the.
Like
I want to see the.
the-
minute.
the-
It could probably be like a traffic. Probably the reason why it was like a duration that long. I mean,
no.
there's a
So
lot of factors. Yeah.
yeah. So Ken, like you read the thing that store and forward flag. What exactly that is?
I have to read it again. Actually.
Yeah, so what we are doing is basically that store and forward flag. It is telling you that if that store and forward flag is n, that means there was the what do you say, like the network was not good from the vehicle to the vendor, so that like the
Oh.
vendor was not able to know whether like the vehicle has reached at a particular location or not. So the thing
Is
is,
that is it N is bad internet and Y is good internet, or
correct, yeah, yeah.
was it wasn't the other way around, was it?
No. N is like bad. N, I think N is basic. Oh, okay. Can you check?
Because N is the natural state. The Y's were so small would mean that the the, the the network is almost always screwed up. And
No,
if,
but
if we look at
okay.
Oh.
can we look at that data definition
Right,
again?
right.
N is I think N represents as you said, the natural state where probably those are Boolean values, right? Yes and no. So
This way, whether the
why
trip was held.
you
Oh,
store
okay,
and not
right, yeah,
okay,
yeah. It's
not
the
not
reverse. It's
store.
the reverse. It's the
Oh,
reverse.
okay, right.
So how is?
Oh yeah, Y is the bad internet.
Yeah, why is the bad internet?
Yes, okay.
or
So, but
store and forward basically means that the internet was like iffy. It was not
Yeah,
good
yeah.
at all.
So the
Okay.
vehicle had to store the information and wait till it had a chance to connect at some point
Right,
later
so-
and
oh,
upload
okay,
the data.
okay.
So
So I think
so
yeah.
do we have to focus on the store and forward flag for now, or should we focus on those that are not store and forward first? You know what I'm saying?
I think we're just exploring the data right now, so we're not like really focused on anything. We're just trying to get a
Yeah.
better sense of everything.
Yeah, we're theorizing here. You know, you would think
Right.
if the internet is bad, that
Is there
could
a
tend
way
to
to
make
filter?
things,
Is there a way to filter for all groups that are not store and forward? Like
Yeah, so we
Yeah.
basically, I don't know when you hopped in, but basically the first thing we did was we just checked accounts. So you could see that most trips are
Right.
not storing. Most of them have connectivity.
okay, gotcha.
There's only 8,000 trips, which is actually very, very small number of trips
That's very small, right?
with this data set. Yeah.
Yeah, that's like almost like less than 10%. Oh, sorry, like 1% of or like 8% of the
Yeah,
um,
but
data.
Yeah, because 1,000 is like 0.1% of a million. So this is, yeah.
Yeah. So
So it's like 0.8? No, it's like less than 0.8. It's like
less than 0.8%.
0.3.
Yeah.
0.3%. Yeah, it's very small.
Yeah, we should probably filter just focusing on the values that are not stored forward for now, maybe. I just want to see. Yeah. That way, there's no like variance within the data set.
Yeah.
Um,
But like you are trying to eliminate a real world scenario and just considering like hypothetical situations. I mean, that's not good for the model because like even that delay is a real case scenario. So
right.
that data would also be matter because like Sweeper said, that data could be dependent on the location as well. What if the location is completely obscure where there are like no network towers? So you basically are
Right.
saying, I mean, if we remove that data, then it would be like the trip. Our system model won't be able to identify any kind of trip which is in those locations. So that's like a drawback.
Yeah, but with this like definition of store and forward, it's like there's inconsistency with the data, which makes it. I mean, um,
It's it's not inconsistency because as you see like it's not affecting the average duration like of because in both the cases if we did the average, so if you see the
right.
average like it's you can see the difference in trip duration. It's not like major difference.
You know,
So
Right. Okay. Okay. I
Actually,
see.
actually, to be honest, there it might be a big difference though, Aditya, because if you look at this, the max trip duration, this is definitely an error, because that's 40 days. You're telling me this
yeah.
many seconds is 40 days. There's no way that trip was 40 days. So that means that this trip duration here on the average is much higher than it should be. This 958 is much higher than it should be, and it's
it,
being affected by
But
these
those are
things.
outliers actually, so you
This
can get rid of those outliers only, but
That's what I'm
you
saying.
don't
but
need.
that
Once we
Yeah.
get rid of this 40-day trip, and if there are any other 40-day trips or trips that
Yeah.
are just errors in the data, this trip duration and the average is going to go way down, meaning that if there were no connectivity issues, that trips are much faster.
but we
Yeah,
know
we can
we
get
know
that.
that's seconds.
Yeah.
Yes.
Yeah, yeah.
So and then well, you look at for the maximum of the Y to be how many minutes does that come out to? That 9900.
This one
Um,
here.
no, the maximum of the Y
Oh,
Just the
yeah.
Y.
internet problem.
300. 3 million. Yeah. 3,050,052.
I mean the smaller number. I mean I guess divide by 60, so it's
99.84,
15 minutes.
166 minutes. So 2 hours?
Is it?
Mm, that's in seconds, right? So,
Yeah.
Okay.
So
I guess that
166 minutes, yep. 2.7
okay. So
hours.
that's a pretty. I didn't I didn't realize it was that. So that's a pretty solid number for
That sounds
a New
possible.
York City. I mean, yeah, that's like
Whereas this
not
one
that that's
doesn't
small.
sound. This one doesn't sound possible. The thing is,
Yeah.
if you look at here, if you look at the number where there was service, so the 1,450,000, there's way more likely that we're gonna get errors in the data. So when we come here and look at the max, this one is 40 days. So the chances that this is the only 40-day error in the nose is unlikely. So I want to check out like the far max end. Like I want to check out like the top
Yeah.
20 max. Like are there other errors that are like this? Because if there are other errors that are as large as this, then this 958 is going to be much lower. And if there is connectivity versus if there's not connectivity, is actually going to have a larger impact on the trip duration than we're thinking right now.
Yeah, I think we want to look at graphs of each one of these sort of X by duration.
right.
Yeah,
And
we
and
could
then it'll be clear what the outliers are. So like think about it. What would be the maximum of a taxi ride if it's limited to the city? Somebody might say, hey, take me from New York City to Albany, and it takes 3 hours. But even that's but it's not. We can the graph will tell us.
Aditya, do you know how to find, instead of just finding the top, like the max, if we could find like the top 20 maxes? Is there a
Top
way to
20
do?
maxes. So
Yeah, like can we see
you need
like
to sort them based on trip duration, and then get the
Filter it.
head of that top five.
so df dot group
I'm not sure how sort function. Like someone can type on the chat if they get to know.
Does it take an argument in the min max function?
Based on
sort from greatest to least. I think I hear you typing, so I'll hang.
No, I'm just like searching, just to like, yeah. Okay. Yeah, this is the one.
You wanna just type it in chat?
Yeah, I mean, yeah, just typing it. 1 second. Print only the row. I'm just checking. Like, I'm not sure if that's right, but okay, it's like this. Trip duration. So it's something like this. So that will sort the thing, and then like us. I'm not sure if it.
No.
There's also n largest is also an alternative way of doing it.
Yeah, that's one more way.
You wanna post it in the chat?
So maybe df sort values.
Yeah, it's df sort values.
df dot sort underscore values. There we go. Alright, yeah, so we have a ton that are like, let's check just the 86,000.
But I have a question, Jim. Like, how could you say that it's an outlier? It may not be an outlier.
40 days for a trip though?
Yeah, I mean, like, just
What do you
we
think?
have to also check the
Could
other
it-
factors as well.
Could it actually be like a 40-day trip that actually? is
What
that,
if, yeah,
like,
what if it's
that
like
is
a long?
I just think that's silly. I think a 40-day trip in New York City is just like,
No, but what if like
Like
I
Moses.
mean, it could be an outlier, but like, what if like it's like what do you say? It's kind of like someone has like rent a car or something for 40 days or something.
But this
So
is
I am
it-
perfectly
taxi
confident.
data, right?
Yeah, this one is possible. The 86,000 is possible because this is just under a day. So if it's just under a day, I could see like the trip started in New York and they were going to Florida or something. So like this seems
No,
possible.
no. No, I'm perfectly confident that anything over 4 hours is not a real trip.
Okay, how are you confident about that?
So there's some clear artifacts in the data. When we do ETL, we can clean the data. We can remove what we believe are outliers. But often a data set comes to us already manipulated in some way. And it's pretty clear that around 86,400 seconds, there's been some trimming of data. But also, if you look at any of these that have very large distance, very large duration, the lat longs are just crazy. We've got observations in Nova Scotia, Canada, in the wilderness north of Ontario. We've got a service center that manufactured the meter located in San Jose, California. We've got observations in the North Atlantic. There's all manner of just, things that are clearly not
Possible.
taxi rides.
Yeah. All right, that makes sense. And when we visualize the data, that'll become obvious too. We're just sort of exploring things right now and just hypothesizing.
right? We even have the longitude and the latitude, like
Yeah.
like data, so we can possibly like create a what is that geographic data map.
Yeah,
So we
I
can
mean,
have it-
just even looking at this latitude and longitude, JH is right. If the pickup longitude is 73, drop off longitude is -73, the pickup latitude is 40, and the drop off latitude is 40, there's no way this trip took a day.
Yeah.
It just didn't. So that's definitely an error.
Yeah, there's even worse examples in there. There's a really fun one, 5-minute duration. It's 303 seconds that starts in New York City and ends in the North Atlantic Ocean. And in 5 minutes, you'd have to go almost the speed of light to do that. You couldn't even get on a 747 and accomplish that.
Yeah. Okay, cool. Yeah, so there definitely is errors in the data that are affecting whether the service or not having service is reliable or.
What is sorry, can we what is the problem statement again for this project? I forgot. Is it just
I'm gonna post you the link in Kaggle too. Who's asking?
Yeah.
Ken, right? Okay.
Yeah, I'm asking. Actually, I got it. I got the link.
All right, cool. Yeah, I believe we're just predicting the duration of the current trip based on previous trips.
Oh, okay. I see.
Mm-hmm. Yep.
Okay, so we're just predicting the duration. Okay.
Yeah, so there's definitely errors here. All right, cool. So I did this just because we did this in the last project, and I wanted to see what it looked like here.
Yeah, df.describe.
Mm-hmm.
I'm going to quibble on. I wouldn't exactly call it an error. I'd call it an artifact. If you're looking at your ruler or another lab device that's measuring the world, you can talk about errors in measurement. Here, there was some process that created the data that arrived on our hard drive. And that process has artifacts, including like clipping things that were much longer than one day. And we can grumble about those artifacts. We can shake our fists and go talk to the people who produce those artifacts. But it's different from a measurement error in the physical world.
Define artifacts again. Is it just basically like data that is that shows like an outlier to the I don't know, it's like an outlier?
So for example, if your data collection protocol is once a day for 7 days, I go out and I visit all the taxi cab meters and I plug in a cable and I download the data. And inevitably, for a few of those taxis, I don't find the taxi in the garage and I don't download the data. If I'm following a protocol and the protocol doesn't collect 100% of the data that it might have, we call that an artifact in the data collection. If you look at this particular data set, it's very clear that someone filtered things that were much more than 86,400 seconds, and that would be another kind of artifact. It's the pre-processing that we don't have visibility into. We can just infer that clipping happened.
I see. Okay.
That makes sense. And then, but we're gonna do our best to normalize all this data and cut out all the stuff that negatively affects our model anyway. So, but yeah, that'll come. Does anyone want to explain this a little bit? Because I remember coming over this, but I'm not big on the statistics stuff, and I have an idea of what this is. So, like, the mean is obviously the average of all of them.
It's like percentile. So 25 percentile means basically like 25% of the entire population has those kind of values. 50% of the entire population has those kind of values, following those kind of values.
It's lower. It's 25% is lower than that number.
Okay.
50% is lower than that number. 75 is lower than that number.
Yeah. I mean, range. Yeah, right.
Yeah, you're right. Yeah. So.
Okay.
So 50th is called median, and 25th and 75th are quartile. A good term to ask Google or Wikipedia about would be IQR, the interquartile range. And if you know the mean and the median, those are certainly interesting. But if you know the IQR, you know a little bit more about the distribution of your data, because it helps you to distinguish between sort of a tight Gaussian distribution and one that is very spread out. If the IQR is large, that is telling you that sort of the standard deviation is large, or that it's a diffuse Gaussian.
Okay.
Mm-hmm.
So that's a whole nother. That's not one of the things we're seeing here. That IQR. That's
Yeah,
not
but
another name for anything here.
Well, I was just saying that by subtracting 25th from 75th, that immediately gives you the IQR. So just looking at it, you can sort of eyeball the RQR. You can
Oh,
tell
okay.
if it's a fat Gaussian or not.
Ah. Another way to sort of remember this, if it, when you used to take those tests in school, and they'd come back and they'd say, "Oh, you scored in the, 85th percentile or 90th percentile." It means that you've got a higher score than 85% of the other people.
Mm-hmm.
So, just to bring it into life experience.
Mm-hmm. Is there anything else we should explore before we start like visualizing the data with graphs and images?
What are the features again? It's
Right here.
okay. So we were just looking at what store and forward flag was.
So, like what JH mentioned, that there are some data sets where the pickup and the drop off time difference is way too large. Sorry, the location difference is way too large compared to the trip duration.
Mm-hmm.
So, if we could find some kind of like use like some kind of uh, like metrics like box plot. I don't know if box plot works in this. Some kind of metrics to identify that difference, just like a stochastic uh, distribution, and see like how exactly that difference is. Then we could like try to kind of remove those kind of data
Yeah, I
samples.
wonder if there's something that exists where it's like if the trip is any longer than 15 minutes per 0.1 mile, or like have like this measurement where like if based on the numbers that we have, this trip is just impossible, can we
So,
just
like,
cut
have a
that data?
threshold.
Yeah,
Right.
like a threshold for like this data is definitely just not
Just
useful.
not right.
Would we cut it out entirely? Would we normalize it? What do we do there? Cut it
We
out,
need
right?
to find that interval. I think that like what could be like the like the interval of the trip duration, and see like the pickup, uh, the locations, uh, somehow, or like the pickup and the drop date time, and use that. Like also like the pickup and the drop date time, that should also somehow like affect the trip duration as well, right?
Mm-hmm.
So we can do
Uh,
this, like we can try to find the correlation between the elements with the trip duration, all the elements, and see how they correlate.
Mm-hmm.
yeah.
Now, do you want
And,
to just based on like the way we did it in the book where we visualized
Uh,
the data before we found the correlations? Do you want to visualize the stuff first, or do you want to jump straight to the correlations, which is
no,
like,
we need to visualize it, because the thing is correlation, for the, I don't know, for the latitude longitude correlation, there should be a way to combine those two. We need to combine, we need to create new columns by combining the latitude, longitude, and the pickup and the drop time to correlate it with the trip duration. We cannot correlate them individually with the trip duration. That won't work.
can we
Yeah,
convert the
absolutely.
latitude longitude to miles or something like, so that we
Yeah,
can?
some kind of uh, like Euclidean distance, actually. We could use that.
Yeah, something that's
Well, great circle distance.
yeah, something more sensible.
Yeah.
Because what is the units that they're using? Actually, wait, let me check.
Units as in, I mean, they're using latitude, longitude. So,
Right.
like, Euclidean distance works with coordinates. So, I don't know. What did you say,
Oh, right,
Jay?
right, right. We should just
I think Jay's
Uh,
mentioned something, right? Like he set some kind of distance formula.
Circle. I don't know.
Yeah, so Mr. Haberstein figured this out for us. We're starting with lat-long degrees or radians, and you can go from coordinates on a sphere to a geodesic along a sphere. The length of that geodesic is the Haberstein distance, and there's a Python package called GeoPy that offers a very convenient distance function.
Oh, okay, cool. Yeah, we can use that.
So first we can create those new columns, I would say. Then it would be easy to visualize because just latitude longitude won't help us to visualize with the trip duration.
Mm-hmm.
Right.
And then you were sort of looking for a velocity column as well, which is simple. It's just divide distance by trip duration.
Correct, yeah. The time basically difference, right?
So
I mean, would it be like the trip duration or like the pickup minus drop time?
So I verified that for 1.5 million rows, there's no artifacts there. That the trip duration is simply the difference of those two.
Yeah, okay. Yeah, then yeah, right. I mean, yeah, I was sure like, but yeah, right, yeah. Trip duration makes sense.
I think we can do these graphs without creating new things first. We can just take a look before we.
Well,
try
you kind of need to store the distance.
Yeah, without
Yeah,
that,
we
you
need the
cannot like.
distance.
go ahead.
What is it? What is the package called? Is it GeoPy?
Yeah, I'm just like putting
That's
it
correct.
here. So this is the, oh sorry, yeah, this is like, it's from actually. I forgot the F.
Oh, there. Oh, yeah. I'm looking at the documentation right now.
Yeah.
What is?
From GeoPy distance import geodesic is GD.
Yeah, GD is the function. So in GD, you need to give like two objects, like it's like tuple, I think. So ignore that. Yeah, right. You just give two. You need to like create tuples of those latitude, longitude, and then give it as the input. So, okay. So what's so the data would have like two latitude at two longitudes, like at every sample would have two latitudes and two longitudes, right? Yeah.
Yes.
Yeah, so you need to like give like this you need to, I think you need to go through every like every row and basically give like this. Okay.
Is there an easy way to create those tuples in Python?
Yeah, I'm just doing that.
Uh-huh.
I mean, let me check. Yeah, so I mean, it's good to use ChatGPT in this case.
Okay.
We're passing in a tuple into the GD function, and then we just give it. Looks like just like the units.
Mm-hmm. Yeah, but I'm not passing in these right here. These are just examples. But I'm taking all of the longitudes and all of the latitudes from pickup and drop off and passing it into this GD function, yeah?
Yeah, it seems, yeah. I'm just looking at the examples as well on the documentation. It looks like
Yeah, I'm typing actually.
I wound up calling this 1.5 million times. It takes about 6 minutes to do it. And Grand Central Station in Midtown Manhattan is very close to the median of the taxi pickups and drop-offs. It's sort of the midpoint between Staten Island and the Bronx. And I just pasted into the channel some code that there's a helper function, distance, that takes a database row and a lat long center coordinate. Grand Central is the center of Manhattan, and it will apply that across all the rows.
Okay.
Ooh.
And yeah, it's good to do minutes because then it's basically minutes per second because we have seconds as the trip duration. So yeah.
Oh, you need a
Yeah, the indentation.
the indentation. Yeah, that's weird. Was it? Excuse
I
me.
think you need to shift everything at the. Oh, okay. You don't need that static method thing. Yeah, you can just shift everything. Yeah.
Yeah, this was on the inside of a class. If you're just using functions, then stealth doesn't count.
Yeah.
Yeah, that's the only reason I hate Python.
Indentation. What?
It's so messed up.
Okay.
Yeah,
Now
now
it's
call the find distance function.
find distance.
With our DF data set as the second argument. What's the CLS as the first one?
Yeah. What
this?
is CLS?
I think you can remove that CLS. Like, I think that's basically the class, I think, somehow.
Yeah.
Correct. Class is like self.
Yeah, self. So you can remove that and run again. Oh, yeah, you don't.
Are you saying just right here,
Yeah.
remove that, remove
Yeah,
this?
remove it
Okay.
and then call
Run
that
it
again and
again.
then call this
And
function.
then
Yeah.
this.
Well,
center,
now I don't have it down here though.
Yeah.
Just call Grand Central without class, and call
What is,
distance without
What's
class.
Grand,
What is
Grand
Grand
Central
Central? Is
should
it?
be a
Is that
need-
longitude
parameter.
and latitude? Is that like longitude and latitude? Like a tuple maybe?
Yeah, I need that.
So what's Grand Central?
In the channel, there's a definition for the lat long of Grand Central.
Oh, okay, cool. So yeah, we could just use it.
Yeah, just directly assign that values. Yeah.
So just get rid of the
What is,
CLS and replace.
You just
Yeah, just replace it with the
yeah.
numbers.
You don't need to do that. The Grand Central equal to. Remove.
Yeah.
Yeah, right. And then you
That
don't need
one's center.
that class.
Center.
No, not center. Don't put
What?
that center. You don't need that center.
What is
Well, before it was class, I can't run distance on nothing.
No. So that distance is a function which you are calling. So you don't need a class to access it. So you remove that class. Just directly call just the distance function.
Really?
Yeah.
Oh yeah, yeah.
Oh
okay,
yeah,
okay.
because of that. Yeah, yeah.
Okay. Find distance.
Yeah, you need to import GOPY.
I did up here. I did right here.
No, you didn't do import GOPY. You basically
And so import geopy.distance.
Yeah, then do from import geo by our distance.
Geopy.distance.
Yeah,
Good. Hit
Yes.
return.
now run it.
Why is the center of the city relevant to the distance between two coordinates?
Yeah, I was just looking for extreme outliers. For example, San Jose, California is very, very far away from Grand Central Station.
Hmm.
Okay, so it's there
And
as
it's a sanity check.
okay. So, but it's not somewhere in there. It's checking to see if it's crazy distance from center, then it's invalid.
Correct. So if you have 1.5 million rows, this takes approximately 6 minutes to run.
Okay, so this could be a while, you're saying.
Yep.
So when I was testing this, I was just using 10,000 rows, and I went through a few edit debug cycles, and once I got it working, then I said, okay, fine, you can do it on the full 1.5 million. So Grand Central is kind of a principled result. I was a little bit surprised that the center was so far west. So Staten Island and the Bronx sort of balance one another out, the median latitude being at 42nd Street makes sense to me. It turns out that there's many more taxi cab rides on the west side of Manhattan than there are in Long Island. And so when you ask for the median longitude, it comes out right around Grand Central.
Yeah. Oh. But Jez, the thing is, I see that this parameter, like the center parameter, is optional. It's not like a required parameter. So if we don't put that, then what would happen? Like, does it like, it would like ignore those records?
That's sort of an idiomatic usage. If I have a constant, so in this case, Grand Central is an arbitrary constant. It came out of some other queries. If I have a constant that I wish to pass into a class method, often I will use keyword default in that way so that a unit test or some other caller can override it. But I'm just giving a hint that, you know, probably this is the usual value that you want to pass in there.
Yeah, no, I'm saying that I understood why. I understood that class function method, like that constant. I'm saying that center values, that Grand Central NYC, like those two values, we don't need to put that as a parameter in that GD function, the distance function. It's optional, actually, I think.
Well, we're computing distance between two things. It happens that during my sanity checks, I was comparing pickup location with center location, but for the distance measure that we were discussing 5 minutes ago, you wouldn't want that. You'd want to compute distance between pickup and drop off.
Correct, yeah. Okay.
Huh. So row
So
drop
this will
off
take
latitude.
6 minutes.
Yep. Yeah, and like, I mean, I don't know how exactly it calculates, because like what exactly it uses to calculate.
So
Oh, there
it
is.
looks like we computed it, and we wouldn't want to discard that result. You want to sort of quickly, before you forget, you want to assign that result to a new column. I would usually do df bracket quote distance equals find distance df. And here I think probably, well, I mean, don't, yeah.
I'm not gonna run it
That's
again.
what I meant, but don't hit return on that.
I'm not. I'm just gonna create a new one.
The result that's being displayed, probably the underscore variable has that. I confess I don't use it very much, but in the interest of like not recomputing it for 6 minutes, you might want to say df bracket quote distance equals underscore, right?
I mean,
Maybe
you
in a
could
new
like
cell.
use that return function as return df of distance, right? And assign it to a new variable, right? You can do that in that function find distance. You can just do return df of distance, right?
Sure.
No, not there, not there. In the find
the
distance
cell.
function, I'm
In
saying.
the cell.
The find distance function, like find distance function, 27.
Uh-huh.
So
Find
the
distance.
one, yeah, you can just return, instead of returning df, you can return like what if we assign this J, what if we assign like this find distance function to a new df variable? So that would add that additional column, right?
Sure. I mean, fundamentally, what's happening is df apply is accepting. Oh goodness, I was trying to say that the df apply returns a series.
Yes, and series is like just like a vector, I guess.
So we could do like pd.data frame, right? After getting the
Sure. So I found this convenient, but yeah, you're right. There's other ways that one could do this.
So don't return df distance. Do it a different way.
Yeah, so you can see that line number 28 of find distance df.
Yes.
So just assign that to like a df variable.
Yeah, that's what I was thinking. But I'm not
And
gonna
then-
rerun it right now. I'm just gonna. I'll just have
Yeah.
that for later.
No, don't do just df. Just df.
is equal to-
Yeah. And then that find distance, put that in a new function, that entire function, that is pd.data frame. D capital, yeah. F capital, I think. I'm not sure.
Mm-hmm.
Well, I'm not sure why you'd want to do that. If you look at the signature and the return, it's a data frame that comes back
Oh,
already.
okay. Yeah, we won't need that then. That's fine. Yeah. I thought that it's not returning a data frame. I was like, okay, fine. That's fine.
So we want to do distance.
No, just df.
Just df, yeah.
Just df, because you're returning a data frame, right? So it should be assigned to a data frame only.
Yeah, but don't we want to create a new column in our df dataset
No, that will create a new column.
called distance?
Yeah, like just assign that to df,
Okay.
and then print df. You will see that new column.
Okay, cool.
Yeah,
I'm not gonna rerun it again, but I'll
No,
do
you
it.
have to like Okay. Oh yeah. Oh, we should have done this before. Oh.
So what I was suggesting a moment ago is, I don't know, maybe assigning df equals underscore would work immediately, because I think that in the course of displaying these 1.5 million rows that include distance in the final column, I think that the Python interpreter assigned the underscore variable to that result. At least it does in the REPL, maybe not here.
So if I just go underneath here and I do df equals underscore, then maybe this column right here will be added.
Yeah.
Okay. Now let's check.
Really?
Yeah, I didn't know this.
I didn't know that too.
Actually, info will give us all of the attributes now, and that should be added,
Yeah.
right?
Mm-hmm.
Yes.
Nice.
Woohoo for the win.
We got it. Nice. Cool. Awesome. So now
So
we have
if
this.
I could phrase that more simply, if you're in the REPL, you're at a bash prompt, you type Python, and then you type 2 + 3. If you ask about the underscore variable, it'll report that underscore equals 5.
That makes sense.
Okay. That's good to know.
Is it like
REPL
is it
being
like
read, evaluate, print loop?
yeah? Is it like a this operator? It works or something like
No,
it
it's just a
based-
convenience thing.
Oh, okay.
It's for convenience. So you can say like 2 + 3, it reports 5. And now if you said, what's underscore squared, it would report 25.
Oh, that's cool.
Wow. Nice.
Okay, cool. So now we have the distance column here.
Yes.
All right.
So what did it say miles, right? Like
So GeoPy reported this in meters. You can maybe see that in the definition, .m for meter instead of like .mi for mile.
Okay.
And it's my opinion that anything beyond 60,000 meters, beyond 60 clicks, is bogus. It's not a fare that the TLC would recognize.
Yeah. You could also create that one more column as velocity. Just do velocity is equal to distance divided by trip duration.
Oh, good.
Just do DF of-
Distance divided by trip duration.
Oh,
Yeah.
yeah, right, yeah.
Yeah.
Distance divided by trip. So velocity is equal to df of distance.
Oops. Distance.
Oh, that would tell us this. Yeah, that
Divide
would
by-
definitely be very useful.
Uh,
How fast the.
yeah, I'd say use like double slash so that it doesn't. I mean, it's fine. It creates.
But
flow.
this is just the average. The average
Yeah.
velocity.
Okay. So we have distance divided by trip duration is going to add a column of velocity. right?
Seconds.
You could put the metric in the title if you want it. Say like meters per second, whatever it's going to turn out
Yeah,
to be.
it will be meters.
Well, this is
Yeah, it'll be meters.
yeah.
per
This is SI. This is System International. So if you are foolish and you ignore SI, if you start using like feet or yards or furlongs or miles, then you have an obligation to put like underscore MI at the end of your variable. But here it's obvious that duration is the natural unit in SI seconds, and distance is the natural unit meters. So we get meters per second.
Yeah, so this will give us the standard
I
velocity.
mean, back in my country, I never heard the term miles. We used to only work with meters per second.
Yeah.
So I like meters per second.
Yeah. Info? Yeah.
All right, so we got velocity too. Cool.
Oh,
And
can we
they're-
can we
they're
see
both-
the velocity? Like, can we see
Yeah,
that?
you can just like head. You can do.
Head? Yeah. DF head.
Yeah. df dot head. Cool.
Oh,
Yeah, that should be good. 455 into 4.
4 meters. 4
Yeah.
meters per second.
Okay.
So, yeah, I mean it's good that it's less than. I don't know. Yeah. So now we can do the correlation. Yeah, we can. I think we can do like correlation, or like we can do that plot for all the parameters, like the distribution plot.
And keep in mind the distance is not the literal distance of the trip, because this is a straight line, and we've got roads and
Yeah, it's not a
Things to
straight
follow.
line. I think. I don't know what the GD does. I think, because I don't think it's a straight line.
well, it may be curved along the earth, maybe, but it's not.
Yeah.
It's not calculating traffic or the
True,
streets
yeah.
of New York City.
Yeah,
True.
the routes.
Corrected. It's crow 5 distance from an L1 norm distance through speed block.
Your voice is breaking.
Recall
Is it
that-
just-
Your voice is breaking.
You're breaking a little bit.
Sorry.
No, you're
It's
good.
crow the function for
I can't hear you at all.
We're having
from
trouble hearing you.
thing
I think.
distance.
Well,
I
yeah.
would say try to reconnect there. Whoever was just talking, because the audio is bad.
Yeah. This will, I mean, at least this will give us like some metric of a distance and something we can work with. So, at least that's fair. I mean, it doesn't have to be correctly accurate, but it's
Yeah, you
something
can
that-
weed out what's like physically impossible.
Yes, yes. So it should work. We can work with this data. So.
All right, cool. So is it time to visualize the stuff, or are we going straight to the correlations? Because even still, when we did the end-to-end project, we visualized everything before we did any correlations.
Yeah, we'll visualize it.
Now, all right. So I basically want to plot very similar to the way that we did it before, right?
Yeah.
Let me see if
I
I
think
can
you can
find.
open that. Oh yeah, right. I thought that you did that Google collab thing.
I did have it open. I closed it by accident. Let's see. So we go
Jay
to.
said that recall that we computed the pickup to grand central distance, which is different from pickup to drop distance. So,
Oh, so so that's not like the trip distance.
yeah, it's just from pickup to grand central distance that
Oh,
we just
so
calculated.
okay.
The only reason that I computed it is I was trying to discard outliers. I was not trying to compute velocity.
Oh, so we need to remove that velocity. We need to recompute that separately, like by checking the distance from. Yeah.
You want to drop it? Should we drop it?
No, don't drop the distance thing.
The velocity.
Just the velocity one because that velocity won't be right. I mean,
Yeah, so we just
it's
drop.
yeah.
Well, you just want to recompute distance. It'll cost another 6 minutes to call the.
Yeah. Yeah. I mean, first, what we can do is we can try to at least get, since we have that part, let's try to get the outliers through that distance object, at least for now. And then we can recompute it separately. What do you say?
Yeah, that's fair. Yeah.
Anyways, we have computed this much, so let's get the outliers first. So,
Yeah.
uh,
Yeah, you're right. Let's just work on the what we have
so
right now.
yeah, so we can do like a box plot where the mean would be the grand central uh, point, and then like a 0, 0, like just do a box plot on the distance. Let me see how to do it.
Mm-hmm. And then so
So
we're
that
gonna
will
get
tell
rid
you
of
like
this.
the outlier.
We're gonna get rid of this duration entirely, right?
Yeah, the velocity.
The
we're gonna
velocity
get
basically.
the velocity.
Like we completed
that
it.
one-
Yeah.
Yeah,
Okay,
that one's based on the grand central.
cool.
But you can leave that line there because you can go back and edit the stuff and then recompute it.
It's alright. Yeah, we can do it.
Cool. Cool. Yeah, so this right here. It's all good. All right, so we do still have the velocity, but we'll just focus on the distance for right now. And you're just getting the code to actually draw that map right now?
The box. plot, yeah.
The box plot. So box plot will tell us like how the data is varied as well.
Mm-hmm. Cool.
And just like
What do you just use ChatGPT?
yeah, that's easy for now, like because it's better to like quickly get the info. Okay, do this. Pip install, like okay, no, you don't have to do pip install. Yeah.
You can just say import seaborn.
Yeah. Like this. Just do this. Pandas you should already have, so you don't need that. And then basically do this. So this will have. I just want to see if this works, but yeah, it should work. So. That's it. Like Arish, I'm seeing the Discord screen.
Just try that out.
Yeah. But I'm seeing the okay, sorry. Yeah, and then yeah, just do that plot. It should give you like a box plot, but I'm just checking.
Oh.
It's why is it so? Is it like I have not used the wrong correct axis. The
You
distance should be
have X.
vertical.
You have
The
X, but you
dis-
don't have a Y.
yeah, the distance should be vertical and y should be, what should be the y? Y should be just the vendor, like the ID, like the trip ID. So give y equal to distance. Just change that x to y, and give x equal to the, like, see if this what happened. X equal to the trip ID. Like for all the records, we need to do that. So
ID. It's just
ID,
ID, right?
Yeah.
Yes, ID. All right, cool.
see how it looks.
Oh god.
No. Oh, all the records.
Yeah, because it's gonna. Uh,
Yeah,
it's gonna
many
be a
records,
huge
right?
graph. Yeah, huge,
Yeah,
huge graph.
I would have thought we wanted distance by duration.
No.
An ID number, graphing an ID number. I don't think that's ever
No. So the
makes
thing,
sense.
sweeper, like the way we calculated the distance was not from pickup to drop.
I understand it was something to the center, but
So we are trying to
which
find like how far the like what are the records which are like way too far from the center. So what I'm trying to do is for all the records, we are trying to vertically plot the distance value and see like how, like what is the, how varied the points are. So there could be some points which are like way too up or way too down, and some would
what
be
is
in the same range.
what is the ID field going to
ID is like it is going to
attribute
go through
to?
every trip ID to plot their distance basically.
Yeah, so it's gonna be like. Oh my god, it's gonna be like a huge box. I think.
Or
with,
they'll
like,
all be
a
just
di-
be
a
squished.
diagonal.
They'll be squished
With like a
together.
diagonal.
Do we even know if the ID is numerical and not? It could be alphanumeric.
Nah, we
We
saw.
can use ID
No, I
as
mean, yeah,
like a label. We can use an ID as a label for a graph.
yeah, but
The
the
ID
thing,
is an object.
It's an ID object.
yeah, but like still like it will basically plot all the IDs. I mean, what could be, because there's such huge data, then what could be a easy way to like because we need to get all the values, right? We could find like values which are like we could get the extreme top 20 high values. We could do that way as well instead
Well,
of using all the values.
the x-axis is, I mean, we're making a graph here, right? So the x-axis is going to be, it's going to start at 0 and then go up to a million or
Yeah,
whatever, and then be focused on, probably some small 6-digit range or whatever those ID numbers look like. I still don't see how this is a graph of, unless I'm just
No, we're
misinterpreting
gonna see the outliers. I don't think the
and
ID
why.
I don't think the attribute that we put in X even matters. We just need something to put in X.
we just need to see all the points
Yeah.
vertically for the y-axis, the
Yeah.
distance of all the points. That's the only reason I put ID. Otherwise,
I mean, you could have
What-
just done just the distance.
yeah, but like I'm just seeing
Well,
like
while we wait on this, go to the the chapter 2 and look at what they did to create
yeah
those.
they have not done the box plot, but yeah,
Oh,
because that data set is way, like it's kind of different than what we have now data set. In our data set, it's more about like lot of out. In that data set, you didn't had like so many out. You just check what were the outliers in that data set.
in this
Like in
one
the,
you had houses over 500,000, for example,
oh yeah, we could do that then. Yeah, like close it. Like
over 50 years of age.
yeah, just stop it, and we could do that.
Yeah,
And
because we do want to see more than just the distance. We want to see also
all the
N and
points. Yeah,
N. Yeah.
just press again. It won't stop. What the hell? Yeah, now it's good. Cancel it. No, cancel it. Oh,
I did.
it will. You have to run everything again now.
Yeah, but I'm not trying to. I'm not trying to run this. I want to see all of them.
No, it said restart runtime, so it will stop. Like I think all the above commands which you have typed, everything would go away. But try it. Let's just run. Just do that. Don't not just print df. Just print df and see if it works.
I think I'm gonna have to run them all again.
Yeah. So when it asks you restart runtime, don't say yes because that restarts the entire platform.
Yeah.
So like never do restart runtime. Yeah.
All right.
Just
Well,
do-
what I'm gonna do is I have to do the runtime, so I'll just run all, and then we can figure out how to make the plot while this is executing here.
Yeah, you can go to that. I think chapter 2. I think we can use that info on.
Yeah, the
So housing, histogram, bins, 50, fig size, 12.8. But this is for every single one, right?
Yeah, I mean we can visualize every factor, right? That's fine.
All right. And
The thing is, this will also still take a lot of time. I mean,
that's okay though. At least we'll get at least what we see will be good.
yeah.
But then we also have save fig, which is extra code. Do we need this here?
No, don't do save fig. Just just do plt.show. I mean, we can save it, but like I'm not sure. Actually, it shouldn't take much time. So, like, just do just do without save, and then later on, if we need it, we can save it.
Yeah. All right. So we got font, axis, legend, xtick, ytick, and then this is actually going to create the histogram for each one of the columns, and then we're going to show. So it's going to show each one of them, right?
that should be the case. Yep.
Cool. All right. Well, I just gotta wait for everything else to load, and then we'll get to it. We'll
Yeah,
try it
only
out.
one thing
Cool.
is left to load.
Though
that?
this is gonna
Oh.
take a long time because this is gonna show 9. Well, this is gonna. How many attributes do we have? We have now. We have all of these, right? So this is gonna take.
You could like create a separate data frame and then in that remove those latitude, longitude because they are not going to like show you any info with the distribution. Like,
Remove latitude, longitude. Yeah, but he said that there were
Yeah, but, like-
outliers in those too.
but like those individually you cannot do anything. Like, I mean, you can, but like, I don't know if it would be good to visualize them individually rather than a pair.
What about the ones that's in like the Atlantic Ocean that you know that it's not true, but the distance is small?
Yeah, I think we want to look
Yeah.
at
Yeah.
everything from the raw level.
Okay.
You
I
know,
mean-
because things will jump out, potentially.
Yeah, I mean, like we had calculated that distance variable, right? Which is basically irrespective of the, like what the info they have given, because that distance will basically it's kind of latitude, longitude only. That's what I'm
You
saying.
know, I don't know that if the distance involving Grand Central Station is exactly going to give us all our outliers. Because what is it? The start position to the center or the end position to the center? We're losing the other half.
Yeah, could be.
So-
Yeah, true.
Let's visualize everything. Yeah, that makes sense.
Yeah, can't hurt. This is probably gonna be the last thing we do tonight, anyways, because we got about 10 minutes. So looks like.
Jim,
All right, so
what was
find
the
distance.
line? What was the line that you took out? The second to last line on that second part.
Oh, just the velocity.
Oh, I mean on what the very last panel when you copied it from the book stuff. There was one
Um,
line, the second to last line.
Oh, I
You
think
took
it
out
was.
that
I think it
and-
was just the other info. So I did an info up here. It was the info that was showing
oh.
the info with the distance.
Oh, I thought it was something you copied, and it happened so quick I didn't notice what was what it
Nah.
was.
Nah, just the info. I deleted the velocity, the one that created the velocity, and I deleted the info.
Okay.
Mm-hmm. So once this one
So
goes,
we have
then this.
10. We have 10 minutes remaining, and on the topic of time, I'll just remind folks that when doing this kind of exploration, it can be interesting to look at 1.5 million rows or 100 million rows, but often it's worth your while to just work on like 10,000 rows. They definitely fit in memory, and you can process them quickly, and so you can go through your edit debug cycle quickly. And when you get it working for the 10,000 rows, then go for 1 million.
Yeah, so we're not loading this whole plot, and then we're like, wait, this isn't right.
Yeah. What if like we use like create like multiple 10,000, visualize multiple 10,000 rows, randomly pick a subset from the total data? That would also work, right?
Yeah, but can we just get a 10,000 rows right now? So can we do like a DF? How we split this into just 10, like the first 10,000 rows? That way we could just make sure that our plot works with those
I mean,
10,000.
yeah, you could like so like you could first like do that sort thing, I think, because we need to get like getting the outliers, so it's better to like sort them descending order, and then we did that above, right? The sort thing.
But we don't have to sort it. We could just take like the first 10,000 rows. It
Oh,
doesn't.
okay.
Yeah.
Yeah, so then just do like first, I think it should be like square bracket or 1:10, right? I think.
Like that. That'll give us the. Is that going to give us? This is the first 10,000, I think, right? Find out, because I don't want to get like everything
Yeah.
except the last 10,000 or something. Let me see.
You're doing the right thing. It's good.
That's good. This right here. So that'll give us the first 10,000, and then I'll just use 10 right here instead.
Yep.
All right, cool.
Yeah, just saying it to remind myself, the colon notation is the first thing is
There we go.
start, stop, and then step size.
Say that again.
The colon notation in Python when you're splitting things up, it's the first thing is the start, the second thing is the end, and the next one is the step size.
Yep. Yeah, you're correct.
Okay. So vendor ID. It looks like there's 2 vendors. Passenger count. It looks like most of the time there's 1 passenger. Sometimes there's 2. Very rarely do we have 3 or more. Pickup longitude is basically in the same area in New York City. And I wonder what these locations are. Trip duration.
Can you like increase the number of bins? I don't know, that distance object, the bins are like, I feel like 5 bins are like too less or something. I don't know. Bins, I mean,
There's 50 bins.
not bins actually, sorry. Like I want to what was I saying? Like the scale actually. I'm talking about the scale for the distance. Oh, 500 will be too much.
Try it
No,
out.
I
I
don't
just
think
wanna.
500.
I just wanna see.
Oh gosh.
Oh, okay. That's not bad. That's not bad though, but
So as far as the longitude goes, sometimes people get picked up in the 5 boroughs and they go west to New Jersey or Philadelphia. The little blips you're seeing in the longitude there is usually people start at an airport like JFK on Long Island in Queens, and they go eastbound. So they leave the 5 boroughs and they go into Nassau County on Long Island.
for the distance, you're saying?
For the pickup longitude. Or sorry,
This here.
Actually, the pickup longitude, I guess those are people out in Nassau that are grabbing a taxi into an airport. Long distance trips tend to correspond to airports.
That makes sense. True.
So for the drop off longitude, I'm fairly confident with that explanation that like minus 73.8 corresponds to sort of Montauk Point in Long Island. For the pickup, that surprises me a little bit because it's much easier to get picked up within the 5 boroughs and leave than it is to like call a cab to come pick me up in Stamford, Connecticut.
They're still almost identical though, right? The range is just smaller here.
Okay.
Like the range from left
How
to
many?
right.
Yeah, how many different vendors are there?
2.
And are vendors cab companies or cabbies?
No, the vendor is the measurement equipment. The vendor, there's only 2 vendors, and there were in the year that this data was collected, there were sort of a bake-off between the vendors that the TLC was conducting to see if they were good. So one of the vendors, Verifone, very seldom will have the flag set that says that they were out of range and the radio was not working, and so we had to store the record and forward it later. The other vendor, I think, is Global Communications, did much better in that regard.
Okay, I thought we were dealing with cabbies, which would have been an interesting point to say, well, if you some cabbies will get you there quicker or slower. And they should have that.
That's true.
But,
if you look at the competition in other years, you get granularity down to Lyft versus Uber versus Yellow Cab.
Right.
How come we can't see the yes or the no for the storm forward flag?
Because it's categorical. It's not continuous.
Yeah. True. What else is categorical that we're not seeing? It looks like, let's look at info really quickly. So we have
vendor ID is categorical.
ID, pickup, date and time, and store. Yeah, all right. So we're missing some of this stuff. I wonder if we could convert that into numerical data and then display that so we can see it as well. If that's even worth doing.
I mean, ID and vendor ID, I don't think you would need, but vendor ID you would need as category. Like you could like use some kind of group by parameter to see how one vendor is performing with the other. Like that could be done for vendor IDs.
I don't think the vendor ID matters. The vendor ID is just the company that like takes the measurements, collects the data, right? That's after the trip. That's not even inside of the trip. That has nothing to do with the trip, right?
I mean, I'm
That's
saying
true.
like, but like if let's say if you want to achieve some other goal, not like to identify trip duration for something like to understand the performance of the 2 vendors through this data, you could do it in that way. That's what I'm saying.
And what do you mean by performance of the vendor?
I mean, like the way they are, like, I mean, performance as in like, how could I say, like, let's say if this one vendor is collecting data which is like has too many outliers than the other vendor, so you could say like the way they are collecting data is like that could be like, I mean, this data is like this vendor is collecting like much valid data or something.
Yeah, so what you're saying is that like the equipment that one vendor is using to collect the data is more prone to errors than the other vendor?
Yeah, something like that.
Huh. Yeah, that makes sense. If you're trying to
Yeah,
evaluate the performance of the vendors. Yeah.
We don't know yet what if the vendor ID is informative or not.
Well, I'm
So
betting
if you look
on
at the
vendor
correlations,
Uh-huh.
if you look at the correlations, the vendor ID is not very interesting. The only thing that vendor ID predicts is whether the store and forward flag was turned on. It's much less than 0.1% of all trips where store and forward is turned on, where essentially someone hit a button on the meter and the radio failed to immediately transmit that they hit the button, that, you know, we had to store it, and later when they came back to Midtown and they were in range, then the radio sent it. And so the only thing that I could see getting from the vendor ID is sort of performance of the antenna, or maybe one vendor was correlated with like selling to companies that were in the suburbs that were far away from the radio towers.
That makes sense. Cool. It is 7:30 right now, so I will be hopping off. We'll be meeting back here again at 6 o'clock, and we'll start off where we left off. I'm curious to explore even more. If we look at the hands-on, I mean, we really did look at a bunch of different visualizations. So I think even just visualizing, I guess drop-off time, date time, pickup and drop-off time, since they are objects, would be interesting. And then also, I would like to visualize the latitude and longitude on the maps. I think that would be cool to just see visualizations of as well, same way that we did in the previous one. And then, yeah. And then we'll start getting into correlations, right?
Yep.
Yeah, correlations and that sort of thing. And then we'll start preparing for the finding out what algorithms we need and which model we're selecting and all that stuff. Cool.
Yeah, I think through correlation you can understand if you would, that would help to understand if we would need a linear model or a like a logistic model.
Mm-hmm.
Yeah.
Cool.
Great meeting. Great meeting.
Thank you, Jim. Thank you, everyone.
Thank you.
Thank you.
Yeah.
Thank you.
Thank you all for coming. See you all tomorrow night. Have a good one.
Yep.